Good afternoon. Good afternoon. Today we are going to solve the same problem by using stiffness method. So we have analyzed portal frame. Analyze portal frame as shown in figure. As shown in figure by stiffness method. By stiffness method. So we are with same problem again. So we have 3 meter, 5 meter, 4 meter, 10 kilonewton, A, B, C, and D. So now we will start with the solution. So we have frame type. So we have sway frame. We have step 1, fixed end moments. As no load between the joints, so we have MFAB equal to MFBA equal to MFBC equal to MFCB equal to MFCD equal to MFDC equal to 0. Then we have step 2. Stiffness matrix. Okay, step 2 we will take kinematic indeterminacy. So we have actually reverse one. So you can have any one. This will be step 1, kinematic indeterminacy. Kinematic indeterminacy. You can take this as step 1, then also it's okay. So we have dk that is equal to 3, theta b, theta c, and delta. Then we have step 3, stiffness matrix. Step 3, stiffness matrix. Now we have to apply one by one value as 1. So we have theta b number 1, theta c number 2, and delta we have number 3. So now we will first apply to theta b equal to 1. So we have this will be frame, and then we will apply theta b equal to 1. So now while applying theta b equal to 1, we have to go clockwise. So clockwise means we have to go on this side. Keep in mind theta a should be 0. So here we have to apply theta b equal to 1. So similarly here also we have to go theta b equal to 1. And then we have this as moment 4 EI by 4. And here we have 4 EI by 5. Then here we will have 2 EI by 4. So this is displacement number 1. This is displacement number 2. And delta we have displacement number 3. So in this we have to add reactions, that is reaction at B and a reaction at C. And therefore we have to show the moment to this separately. So we have this AB moment we have over here 4 EI upon 5. Here also we have 4 EI upon 5. And then these are clockwise. So to balance this, we have this will be anti-clockwise moment RB. Here we do not have any moment. So we have this as 0, which is RC. Now RB we can find, that is moment about A equal to 0. And from this we will get RB is equal to, sorry, this is 2 EI by 5 half. And therefore we will get it as 6 EI by EI upon 5 square. Now we will get values of S11, values of S12. That is again most important. So here we have S1, here we have S2, and here we have S3. Now we have applied unit displacement at 1 because we have applied theta B1, and you can see over here we have B as number 1. So this is S11, then this is S21, S31. And therefore we will get S11 is equal to 4 EI by 5 plus 4 EI by 4, and this value comes 1.8 EI. Now if we will go over here, so we have S21, that is directly 0.5 EI. Now we have S31 equal to RB plus RC, and RB we have now minus 6 EI upon 5 square, and then we will get it as minus 0.24 EI. So this is all values when we have applied unit displacement at 1. Now we will switch over to unit displacement at 2, and that we have theta c. And therefore we have to go, I will first draw the diagrams which we require here also, which is RB and RC. So we have these diagrams also over here. And now we will apply unit displacement, and now we have to apply theta c equal to 1, and then that is again clockwise. So we will have upward 1. Then here it will go clockwise, means inside, and here we have value as theta c equal to 1. So now value of moment we require over here, that is 4 EI by 4, and over here 4 EI by 3. Now due to this we will get half on this side, 2 EI by 4. Now we have, this will be reaction, now this will be 0, no moment we have, and here we have, that is 4 EI by 3, and on this side half we have 2 EI by 3, and we have this value now clockwise. So to balance it, RC will develop anti-clockwise, and RC we will get, add these two, so we have 6 EI upon 3 square, and we will get it as again minus sign, minus 2 EI by 3. Now we will go to stiffness coefficient numbers. So we will have this as S at 1, this will be S at 2, this will be S at 3. Now where we have applied unit displacement at 2, so we have S12, S22 and S32. And then we can write S12 equal to 0.5 EI. Then we have S22 equal to EI plus 4 EI by 3, because this 4 gets cancelled, and we have 7 EI by 3. Then we have S3 2 RB plus RC, and we will get this value minus 2 EI by 3. Now we have third displacement, which is delta. Now we have to apply unit horizontal displacement, and we will draw the diagram. So we will have this and unit horizontal displacement, then we will get in this fashion. Similarly, at other end, that is C also, we have same. So when we are going to get it as delta, so it should be 0 over here. This should be vertical. Here also it should be vertical. So theta B and theta C should be 0. How much moment we require, that actually we will see. Now similarly we will plot for this. And here we have delta equal to 1. So we have delta equal to 1 because we have third, that is delta. Now we will switch over to the values. So how much moment we require for unit displacement? So we require 6 EI delta is 1 upon 5 square. And the same we are going to be over here, which is 6 EI upon 5 square. Now here we have at both places anti-clockwise 6 EI upon 3 square. And here also we have 6 EI upon 3 square. Now here we have actually now 6 EI upon 5 square. This is also 6 EI upon 5 square. So both we are in anti-clockwise. So clockwise moment will be developed. And this will be 12 EI upon 5 cube. Similarly, here we have that is 6 EI upon 3 square. Here also we have 6 EI upon 3 square. And then we have reaction we will get, which will be, this is RB equal to, and RC equal to 12 EI upon 3 cube. And now we will write the values of the coefficients. Then we have this as S at 1, this is S at 2, this is S at 3. Now we have applied unit displacement at 3. So S11, S13, 23 and 33. And there we will get S13 equal to minus 6 EI upon 5 square equal to minus 0.24 EI. Same value we have S31 equal to S31. Then we have S23 minus 6 EI upon 3 square equal to minus 2 EI by 3, which is equal to S32. And now S33 we have to find out, which is equal to RB plus RC, and that is equal to 12 EI upon 5 cube plus 12 EI upon 3 cube. And if we will solve these values, then we are going to get this 12 by 5 cube plus 6 by 3 cube. And we will get it as, 12 by 5 cube plus 12 by 3 cube. And we will have this as 0.54. Now we will switch over to the next step. We have step number completed 3, 4, formation of equations. Formation of equations. Now if we will go general equation, we have FD is equal to FDL plus S into D. Now we have over here FD1 equal to FD2 is equal to FD3 equal to, no, FD3 we do not have 0. So FD1 equal to FD2 equal to 0. Now we will go for FDL. Now we do not have any fixed end moments. So we have FDL1 is equal to FDL2 is equal to FDL3 equal to 0. And now we will write the equation. So we have first equation 0 equal to, now S11 we have 1.8 EI. Then S12 we have 0.51 D1 we have theta B plus we have S12 2.5 EI theta B. 13 we have delta minus 0.24 EI delta. This is 0 plus we can write. So this equation if we will have, this is FD1 is equal to FDL1 plus S11 D1 plus S12 D2 plus S12 13 D3. Now similarly FD2 now we have FD2 is equal to FDL2 plus S11 sorry S21 D1 plus S22 D2 plus S23 D3. And then we have 0 is equal to 0 plus S21. We have 0.5 EI theta B. S22 we have 7 EI by 3 theta C. And S23 we have, that is 23 to 3 to same minus 2 EI upon 3 delta. So now you can see what is first equation we have 1.5 EI theta B plus 0.5 EI theta C. Sorry, this is theta C minus 0.24 EI delta equal to 0. Second equation now we have 0.5 EI theta B plus 7 EI by 3 theta C minus 2 EI by 3 delta equal to 0. Now third equation FD3 equal to FDL3 plus S31D1 plus S32D2 plus S33D3. Now FD3, so we have FD3 equal to 10 because we have delta and at delta we have 10 kilonewton. So we have 10 is equal to 0 plus we have S31. So S31 we have minus 0.24 EI theta B. Then S32 minus 2 by 3 S32. So 32 we have, sorry, S13, S23 and S32 we have same minus 2 EI by 3 delta and S33 we have plus, sorry, theta C and plus 0.54 EI delta. And we will get this equation third minus 0.24 EI theta B minus 2 EI by 3 theta C plus 0.4 EI delta, and that is equal to 10. And solving these three equations, we will get value of EI theta B equal to 1.67. Then EI theta C equal to 7.95 and EI delta equal to, we have 29.07, same as slope deflection. and then we have to use slope deflection method, and then we have to solve the problem. That is for final moments. So now we will stop here only. Remaining part we will see in the next lecture.